So in this following presentation, I will describe a bit more the landscape in which the talks that are coming will take place. So let me start with a little question. The question is, what do you do when you want to run computations on a cluster? Well, the answer, of course, is that you write a submission script and you submit it to the scheduler. So for instance, SLUB or PBS or so on. So you write a submission script, which can look like this. So it's a bash script with commands that are understood as directives by the scheduler, indicating some resource requests, some job parameters, and then some operations that will consume some file and produce some others. We can graphically describe this job as for instance, a dot, in a gray dot in this case here, with some arrows indicating some input being fed to the task and some output resulting from the task. When you have multiple jobs that must run in sequence, for instance, you have pre-processing, actual processing, followed by post-processing, you can graphically represent it like this. And you submit the first job, you wait for its output, and then you submit the second one that will consume that output. And then when that one is completed, you submit the last one, and it's pretty easy to do. But what if the relationships between the jobs look like this? Something maybe where you have a large number of jobs that are very similar and independent. And I will refer to these type of things as a wide workflow. Or if you have a large number of jobs with dependencies between them and the jobs are very different, I will refer to them as deep workflows. Or you can have even workflows that are cyclic, so where the same job must be run multiple times. So I've been using the term workflows because you need to think in terms of workflows when you have many jobs to process. So workflows exist in business, in healthcare, in administration, and in science. And in science, they can be described as a precise description of a scientific procedure. So a multi-step process to coordinate multiple tasks, acting like a sophisticated script. Workflows also exist in IT operations, and we'll see some of it in this workshop. And they appear in machine learning, in Internet of Things, and so on. So workflow basically consists in a list of tasks, which are the work part of the work, and a list of dependencies between the tasks, which implement the flow. But also around it, you have a set of data sources most of the time. You will need computational resources and, of course, some software to process the input to produce the output. The thing with workflows is you don't want to manage them by hand because it's nearly sure you will make error. It will not be nice to do. You will have to make sure you are very precise and you do not make mistake. It's not easy to share because you might end up explaining to a colleague what you did, but again, there's a room for error in the explanation, and you might not be able to precisely recall everything you did, so that sometimes it will be difficult to track provenance. So rather, you will use a workflow management system. Workflow management systems typically can do some or all of the following tasks. So organize dependencies and compute the dependencies between the work and organize the work, submit and monitor jobs to the scheduler, generate job descriptions with templating and so on. Some of them will also install scientific software for you. Some of them, nearly most of them, will take care of failures and so resubmit jobs that fail, for instance. Some of them would manage data, so copy the data back and forth between the system where the computations take place and the system where the data are stored. All of them will help you log everything you did, and so it will make sure that you can actually track provenance. They will for some of them also enable the sharing of the data or of the results and monitor access policies with security and so on, so you can work together as a group and working on the same study. And for the most advanced systems, they will even offer you some performance analysis and prediction. So by giving a description of the job you want to do, it will try to find the optimal size and optimal and maximum length duration of the job. So these are some of the features that you will find in a workflow management system. And actually, even if you never got interested in workflow management systems in the past, I'm sure you already know at least one. And the example is the GNU Make. So GNU Make was designed to help build software from sources. But actually, it can compute dependencies between tasks and organized work. And also, I'm sure you know that Make allows for smart reruns in a sense that if something does not need to be recomputed or rebuilt based on the timestamps of the data files, it will not do it. Even more interesting, actually with a little trick, which is described in this blog post, if you set the shell to be srun, for instance, on Slurm, then you will add the capability to submit jobs to the scheduler. And you can have Make interact with the scheduler and submit jobs for you automatically. Of course, this is not perfect because this is merely a clever hack. But the idea is that with this kind of tool, you will remove a lot of possible mistakes in your work. It will be more convenient because all you have to do is think about everything correctly in the first place, and then you will ask the workflow management system to manage all the details of the job submissions and so on. You can also share your workflows because the workflows are entirely described in a file, which you can document, which you can version and submit to other people for review or for sharing. And then it will be very simple to track provenance because all of the tools will record log of what was done on which data using which software. So the question now is which one to choose. And I'd like here to mention a project called the Common Workflow Language that aims at defining a standard for a language that can describe workflows. In their documentation, they offer an incomplete list of workflow management systems. And that list is actually more than 300 items long. So it's not easy to choose from that. Why are there so many? Well, simply because the requirements can be very different from one application domain to another, and there is no one-size-fits-all solution. So in this workshop, the goal is to help you find the tool that will best fit your needs. We will focus on tools that are relevant to the HPC environment, so not tools that are meant for cloud or Kubernetes or for Hadoop and so on. We will focus on standalone tools, so we will ignore libraries that are linked to a specific language. We will also focus on tools with a simple domain-specific language, so you don't need to learn a very complex language to describe your workflow. We will also focus on general purpose tools. So some tools are very, very efficient, but very reserved for some types of analysis which is specific to an application domain. And of course, we are interested in tools that are mature with some active community and that can be installed easily. In this workshop also, we will have a look at the specific workflow type that is checkpoint restart, because it's important in all types of studies. Most of the time you will have to, at some point, deal with maximum hold times on cluster, and you will have to stop your jobs and restart them later on. We will also have a look at workflows in IT operations with CI/CD, so workflows to deploy and develop software, of course, here in the context of scientific software. We will then feature some testimonials from users who use more complex or advanced tools than the one we'll be presenting, just to illustrate what can be done when a whole team organizes around a workflow management system. Just after this session, we will start with what we already know, namely basic Linux tools, and we'll see that some of them can be very handy for managing jobs on a cluster. So schematically, the workshop will start with this session, as I mentioned. In the next session, I will also talk about Maestro, a very nice little tool that can really help you start. And then we will have a session about checkpoint restart given by my colleague, Olivier. And then later on this afternoon, we'll have a session about A-Tools, which is a nice tool to manage job arrays, so aimed mostly at wide workflows. And then I will talk about Makeflow, which is really based on the idea of a Makefile, but specifically designed for workflows. And this one is more suited for deep workflows. We will also have, that will be tomorrow, a session about Snake Make, which is a bit more complex to manage, but can do a bit more things than A-Tools or Makeflow. And then we will have also 2 sessions by Olivier about Singularity and CI/CD, which are 2 tools which are very convenient in the context of IT operation workflows. And then we will have some user testimonials, which each will illustrate one type of workflow. For those who are interested more in the theoretical aspect, I offer here a list of papers on the subject which you can refer to.